Bernoulli equation, if you look at the formula itself, it looks pretty much like linear equation, except that on the right hand side you have y to the power n. This is show that it's not linear, right? Because the definition of linear differential equation, you shouldn't have any equation that have degree more than higher than 1. But this one to the power n. Okay, so n is n, it shouldn't be equal to 0, and n shouldn't be equal to 1. Other than that, n could be any number, could be fraction, could be real number, not really, like 1, 2, 3, 4, 5, something like that. It can be that. No, cannot be 1, but it can be 2, 3, 4, 5. Can be fraction like a 3 over 2, 5 over 3, something like that. And it can be negative number, like -2, -3, minus whatever, except 0 and 1. Why 0 and 1? Because if n equal to 0, what you got? N equal to 0, y equal, you would get something like this, right? N equal to 0, no, 1. Right? So this equation is a what? Linear equation. You don't need to use Bernoulli in that case. Just go to linear equation. And if n equal to 1, if n equal to 1, it is a separable equation, the first equation that we learned. So we don't need to use Bernoulli. Okay? So other than that, it's called Bernoulli equation. Other n, it's called Bernoulli equation. And the way to solve for the Bernoulli equation, first we got to assume v is equal to y to the power 1 minus n. Let me put Let me put this as the equation 1 and this is equation 2. From equation 2, we do derivative of v by x. We would get what? 1 minus n. You do derivative of it, y, right? You do derivative of v to x and y to x. We are going to change equation 1 from dy by dx to dv by dx. So we got to write down dy by dx equal to equation 3. Then we put 3 and 2 into 1. But we are going to put 3 into 1 first. We would get 1 over 1 over n minus n, sorry, y to the power n dv by dx plus pxy equal to hx y to the power n. We make the coefficient in front of dv by dx equal to 1. Okay, we are going to make the coefficient in front of dv by dx equal to 1. Okay, so we would get something like this. You see, this y divided by y to the power n is equal to y to the power 1 minus n, right? Y to the power 1 minus n is equal to v, which is whatever we assume, right? So this one I would say is equal to v. On the right hand side, you have y to the power n on the top and y to the power n at the bottom. They all cancel out. Now, we would get equation 4. You change the variable from y to v. And now this equation is a linear equation, right? Now this equation 4 is a linear equation. And then, since this is a linear, the way to find the solution is just using the linear differential equation method to solve for the answer. And at the end, you would get v as a function of xv. Then you just change your v back to y by using the definition, the assumption that you make as the equation 2, plug it back in, turn it back to y, and that's it. That is the way. Then you would get the answer. Okay, that's it. Look at the example.